In this question, we're simplifying two fractions as well as to solve a linear inequation. Also, we'll be looking at this compound shape. We'll be finding an expression in terms of x for the length of various parts, for example, for PQ and RQ. Also, as an extended question, well, this is part of the CXC exam past paper question as well, to show that x squared plus x minus 72 equals 0, given that the area is 414 centimeters squared. As an extension though, we will find the value of x. We will also calculate the perimeter of the compound shape and then find the actual perimeter of the shape. Now, these are extension questions, not part of the original question. But just in case the future exam they have those, then you'll know how to do those, right? Now, part 2, let's get on with it. We want to multiply these two fractions. So we're going to divide 4 into 4 and divide 4 into 16 goes 4 times. You always cancel a numerator and a denominator once you're multiplying two fractions using the highest common factor. 5 goes into itself once. 5 is the highest factor of itself. And 5 goes into 15 3 times. Next, we simplify. X cancel out x. X goes into itself once in both cases. Now, 1 times 3 is 3. And 1 times 4 is 4. Now, what we're going to do is transpose the negative 8m to get positive 8m. About the minus 4m. About the inequality symbol. Now, we have 5 there, so we'll leave it there. But we're going to transpose this 12 to the other side as negative 12. Because it's a positive 12, becomes negative 12. Now, 8m minus 4m, that will be 4m. This will be negative 7. Next, we're going to divide both sides by what? 4. Why are we dividing though? Because m is connected to 4 by multiplication, so we do the reverse. And our solution for this is that m is less than or equal to negative 7/4. Also, we can write our answer as we have an improper fraction here, but we can write it also as a mixed number. So 4 goes into 7 once. Let's get back to that. 4 goes in 7 once. Remainder 3/4. So either option is correct. Next, let's look at this compound shape. So the lengths in this diagram, which are written in terms of x, are in centimeters. Write an expression in x for the length of PQ. Now this is only worth 1 mark. So we want the length here, PQ. We do not know the length in terms of x. But we know this length here is 3x from m to n. In other words, if we were to extend this going upwards, it means that from P right up to the top will be the same length as mn because they are parallel and they are opposite sides of a rectangle. So if you notice that this will form a rectangle here. So if this is 3x, it means that this side here from this top right down to P is also 3x. However, we want to remove this length, this dotted line here, from the length of 3x. If we remove this length, in other words, take it away from 3x, we'll have the remaining length, which is QP or PQ. So this length here is the same as this length here. Notice that we have a rectangle here, So if this side is x plus 3, then it means that from this point to Q is also x plus 3. However, we do not want this x plus 3 length to be part of what we're trying to find, which is PQ. So we want to remove that amount. So the entire length again is what? 3x. I'll be subtracting this length out of it, which is x plus 3. Now we need to use bracket to show that we are subtracting the entire x plus 3 quantity. And so that is 3x. Now we're going to negate the signs in the bracket because we have a negative outside. So we think of it as like a negative 1. So negative 1 times x, that's negative x. Negative 1 times 3, that's negative 3. And then we can simplify 3x minus x, that's 2x minus 3. This cannot be simplified any further, so our solution is just 2x minus 3. Hopefully that was clear. Again, the entire length here from this point to this point is 3x. And from it, we are removing this portion that we don't want, the other line here, removing that length. And what will remain? what will remain is simply PQ, since we're taking out x plus 3 out of the entire length of 3x. X plus 3 out of 3x. Next, we're looking at RQ from this point to this point. Okay, so we know from this point L to this point L is what we're searching for, really, right? Because we're looking at R to Q. So this is the same as the opposite side from L right to this point, because right here we have a rectangle as well. We have a rectangle here. And opposite sides of a rectangle are what? The same measurement. And if you look at this line here from this point to this point, which is really RQ in terms of its length. But the entire length is 4x minus 5. In other words, going from L to M is 4x minus 5. But do we want the entire 4x minus 5? Do we want the entire length from L to M? No. Which piece we do not want in terms of length? We do not want this piece right here. If we take out this piece here, what would we be left with? From this length, from this point to this point, which is the same thing as from R to Q or Q to R, because opposite sides are equal. So the entire length is 4x minus 5, and we're taking out this length. Now this length is the same as this length down here, correct? Because opposite sides have the same length. In other words, this length here is the same as what? The opposite length, which is x plus 1. Okay, so if you have a rectangle, this length is x plus 1, this length is also x plus 1. So that's the concept right here. So again, we have 4x minus 5, and we're taking out x plus 1 from it. Once we remove this piece, then we're left with only this length here, from this point to this point, which in fact is really this point to this point, or the length of RQ. So 4x minus 5, subtracting x give us negative x, subtracting 1 give us minus 1. In other words, we distribute by multiplication. Negative 1, treat this as a negative 1 times x, negative 1 times 1 is negative 1. Then we can group the like terms together. You can actually do this in your head because it only worked one mark. And so that will be 3x minus 6. So this length here, RQ, is 3x minus 6. And this length PQ, as we found earlier, is 2x minus 3. Now let's move on to the next question. Let's put back this is 3x minus 6, 2x minus 3. Let's double check. 3x minus 6, 2x minus 3. Okay. Now, given that the total area, there should be area. Given that the total area of the shape is 414 centimeters squared, show that x squared plus x minus 72 is equal to 0. The total area we're told is what? 414. And we want to show that x squared plus x minus 72 equals 0. Any thought on how you do this? Well, take a hint from this fact that this is the total area, right? That's total area. So we can look at the total area from another perspective, from an expression point of view. So if we were to cut this up, let's cut this up. So I can cut it up this way. It doesn't matter which direction. If I could cut this way, or I want to cut it this way. But let's cut it this way. Cutting it this way, then we have this part of the compound shape, which is a rectangle. We have this part of the compound shape as well, which is also a rectangle. And so to find the area, we can find the area of A plus the area of B. That will give us the total area of the compound shape. So let's find the area of A. The area of A can be found by length times width. So if you look at this rectangle here, its length will be what? 3x minus 6, right? This is 3x minus 6 from R to Q. So that's going to be 3x minus 6 multiplied by the width, which is what? X plus 3. Now if you're not seeing that, then I can actually take it out. This is R, L, and this is Q here. And right up to this point that's not named. You can call that K if we want to. Let's call it K. And so this is going to be 3x minus 6, as in the length, and the width is x plus 3, just so you can actually visualize it. And if we want to find the area, multiply the length by the width. So we're multiplying, and we have to use bracket in this case because we're not looking at a term, looking at a binomial, two terms. So we use bracket to show that we're multiplying the entire quantity by the other quantity. Now the area of B now, let's take out B, let's illustrate this so you can actually see it better. So we're looking at P. We actually named this point K, so we're going to put K here. That will be M, and this will be N. Now this length here is X plus 1, and this length here is 3X. So to find the area, we multiply length by width. So this will be the length by the width. The longer side we call it the length. Short side we call it the width. So it's going to be what? 3x times. Let's look at that. Now I didn't have to erase the bracket, but since it's just a monomial, one term, single term, we don't have to put it in bracket. And we show that that single term, the monomial, which is the length of rectangle B, multiplied by the width of rectangle B. Now we're going to put the binomial, the two-term expression. We have two terms, right? Representing the width. So now we have the area of A plus the area of B, which will give us the total area. All right, that will give us a total area. Let's put TA for total area. Okay, now let's expand this. 3x times x will give us 3x squared. Now, why are we doing that? When you're multiplying two binomials, you multiply each term of one by the other terms of the other. So 3x times x, then we're going to multiply 3x times 3, which will give us 9x. Then we're going to take the next term now, negative 6 times x, give us negative 6x, and negative 6 times 3, give us negative 18. Then we're going to distribute this 3x onto the other two terms. So 3x times x is 3x squared, 3x times 1 is 3x. All right, so this is what we're going to simplify. Now we're told that the total area is actually equal to 414. So we can keep putting 414 since the total area is that amount. This side represents the expression in x, and this side represents the actual area. Okay, so let's simplify this. We're going to have 3x squared. Now this is plus 3x squared. Now we can actually do that mentally. You don't have to put it down. And then we're going to have let's go over that. It's 9x minus 6x. We can just write the answer as positive 3x there. We have another 3x here. All right, we're going to simplify then 9x minus 6x. And then put back the 3x. Do we have any constant? Yeah, we have a minus 18 by itself. And I can transpose over the 414, that'll be negative 414. And so we have 0 on this side. But the idea is to get it equal to 0. All right? So now let's continue. Now 3x squared plus 3x squared, that's 6x squared. 3x plus 3x, that's 6x. And when we look at these two quantities, both have negatives, so we're going to add and keep the sign. And if you want to work that out without a calculator, 8 plus 4, that's going to be 12. It's going to be 3 here, 1 plus 1 plus 1. So that's 432 equal 0. All right. Now, if you look at this, we have 6x squared plus 6x minus 432 might equal 0. This is an equation. This is an equation. And so an equation you can actually divide throughout by a constant, a particular number. Now here's the thing. We want to have x squared. We want to start with x squared. And so to get rid of the 6, we will divide throughout by 6. So I'm going to divide each term by 6. I'm going to divide this equation by 6. So this 6x squared will become what? 6 into 6x squared will give us x squared. 6 into 6 will give us 1. That's 1x. And 6 goes into 432 72 times. Use your calculator to double check that. And 6 into 0 is 0. In other words, 0 divided by 6 is 0. Now, if you want to double check in terms of the 432 divided by 6, we can say 6 into 1, 6 goes once. 6 into 42, we know that 6 sevens is 42. So we have an extra 1, we put by the 12. and 6 into 12 goes 2 times. That's it. And so we have just proven, or just showed, that x squared plus x minus 72, as given here, is equal to 0. Now, we were told that we should do what? We were told that we should determine the appropriate value for x. Okay, determine the appropriate value for x. All right, and so how can we solve for x? Well, we have an equation in x, a quadratic equation in x, so we can actually solve that. So we realize it's quadratic. Now first we can attempt to solve it by factorization. So x times x will give us x squared. That's the first by the first. Now the last by the last should give us negative 72. Since the last term is negative, then the signs in the bracket will have to be different, because positive times negative will give us negative. Now, what two quantities multiply to give us 72? That when we do the inner and outer, we get a 1. Well, that would have to be two numbers that are consecutive integers with opposite signs. For instance, when we look at positive 4 and negative 5, these are consecutive integers and we actually get negative 1. When we look at positive 5 and negative 4, these are consecutive integers and we get positive 1 when we simplify. So that's the idea there. But we're looking for 72 and we know 9 times 8 are consecutive integers. When multiply, give us 72. And when we look at, let's take this off quickly. When we look at positive 9 and negative 8, we'll actually get what? Different signs we subtract at 1, and we keep the sign of the 9 since 9 is bigger. That's positive 1. So this will work out, should we multiply it out. All right, this will be 9x, positive 9x, and these two will give us negative 8x. Now when simplified, give us positive 1x, which is the middle term we're looking for. Okay, but now we want to solve for x. So that's the idea, to solve for x. That's what we were told to do. Now, if this quantity multiplied by this quantity gives 0, it means one of these quantity must be 0. For instance, if you're told that p times q equals 0, what do we know about p or q? Well, one of them has to be 0. So either p is 0 or q is 0, or both could be 0. So we say either p equals 0 or q equals 0. In this instance, since we have a binomial, we do the same thing, but we have a binomial though. So we probably have to do another step. So we say either x plus 9 equals 0 or x minus 8 equals 0. Now if x plus 9 is 0, then we can solve for x. So x will be equal to, subtracting 9 from this side will leave x isolated. We subtract 9 from this side will give us negative 9, which seemed like we would have transposed the plus 9 as negative 9. Or transposing the 8, we have x equal positive 8, which is the same thing as adding 8 to negative 8 to cancel, and adding 8 as well to the other side give us 8. Now, can x be equal to negative 9? No, that's not possible, because when we look at the length of this side, if we were to substitute x equal negative 9 and add a 1, then we'd end up with a negative length, and we know that measurement cannot be negative. That wouldn't make any sense. If there's no length, then it's 0. And if we're measuring length, then it has to be greater than 0. And so length cannot be negative. So this is invalid. And so the appropriate value of x would have to be 8. All right, so now let's look at the next question. Remember, this question is not featured on the CXC exam paper. This was just created as an additional problem. But now let's look at the next question, which also just an extension of the CXC problem. Write an expression in x for the perimeter of the compound shape. Well, we know this length RQ as found in the beginning is 3x minus 6, and this one is 2x minus 3. Let's just double check. 3x minus 6 and 2x minus 3. Now, let's find the perimeter of the compound shape. So let's start with L to R. So we're going to start from here. we're going to go in this direction all around. So from L to R is x plus 3. From R to Q is 3x minus 6. So add that length. I'm going to add the next length, which is 2x minus 3. And the next length is x plus 1. And the next length is 3x. And the next length is 4x minus 5. Might be a little harder to see, and grouping them together might miss out on a particular letter. So one thing you can do is probably put the x's under each other, right? So instead of, we could say x plus 3, then 3x minus 6. Let's try that way. See if it's easier for us to actually see what we're doing, so we don't make a mistake that way. So we can say x plus 3, then 3x minus 6, then 2x minus 3, then x plus 1, then 3x, and the next one is 4x minus 5. And let's see, 3 minus 6, that's going to give us negative 3. Negative 3 plus negative 3, that's negative 6. Negative 6 plus 1, that's positive 5. All right, so now we're looking at the question where we're asked to write an expression in x for the parameter of the compound shape. So to find the parameter in terms of x for the compound shape, we can add all the x's. X plus 4x, that's 5x. 5x plus 3x, that's 8x. 8x plus x, that's 9x. Now remember, this length here is 2x minus 3, and this one is 3x minus 6, which we got from the previous parts of the problem, right? So we'd have worked this out before. So again, x plus 4x is 5x, plus 3x is 8x, 9x, and then we have 9 plus 2 is, that's 11x, 11 plus 3, that's 14x. And then we're going to look at the numbers. 3 minus 3, that will give 0. Negative 6 minus 5, since they have the same sign, we add and keep the sign, that's negative 11. And negative 11 plus 1, that will give us negative 10. So that's going to be minus 10. So they asked us to just write. We didn't ask us to calculate, or what we know we'd have to calculate it, but since it's just write, we can just write it down, but actually get the right answer there. If you want to write out the entire thing, that would have been fine. So you'd have written down like x plus 3 plus 4x minus 5 plus 3x plus x plus 1 plus 2x minus 3 plus 3x minus 6. Then you group the x terms together, then group the constants, and then simplify to this 14x minus 10. I just think it's easier just adding the x's and adding the constants. Okay, now the next step is to do what? The next step is to find the actual parameter of the shape using our answer in C1. Now let's look and see what that is talking about. So in C1, what our answer in C1, I think I made an error there. I think that should be C3. All right, so forgive me on my typo there. That would have been in C3, or answer in C3. What was the answer in C3 though? The answer in C3 is x equals 8. That's a valid value of x, right? So the actual parameter can be calculated as 14x minus 10. So that's going to be what? 14 times the value of x being 8 minus 10. And 14 times 8, that's be 80 plus 32, that's 112. Minus 10, you can use your calculator for this. And 112 minus 10, that's 102. And remember, our answers should be in centimeter, the length. And so that is 102 centimeters for the parameter going all around. What though if they ask you to calculate like LR? What's the length here? Well, that will be 8 plus 3. That's 11 centimeters. This length here from R to Q will be what? 3/8 minus 6, that's 24. Minus 6, that's 18 centimeters. This one will be 2/8 minus 3, so that's be 16 minus 3. That'll be 13 centimeters. This is 8 plus 1. That's 9 centimeters. This one will be 3 times 8, which is 24 centimeters. And this length, L to M, will be 4/8. That's 32 minus 5. And 32 minus 5, that's 27 centimeters. So should you add up these lengths, 11, 27, 24, 9, 13, and 18, you should get 102 centimeters. Okay, so let's write 27 plus 11 plus 18 plus 13 plus 9 plus 24. We already have the 27. 4 plus 9 is 13 plus 3. That's 16. 16 plus 8, 24. 24 plus 1, that's 25. 25 plus 7, that's going to be 32. 2 plus 1, that's 3. 4, 5. 5 plus 2, that's 7. And 7 plus 3, that's 10. Correct. All right. Thank you. Hope you liked the video. You can subscribe to the channel if you haven't subscribed already. You can share this video if you want to share with someone that you think it will help. All right. If you have any suggestions as to making these videos better and, tailored for you, then you can also make your comments in the comment section. If you have any positive feedback about the video, you can also share that. Thank you.